Hello guys, today we're going to finish 5.3 partial fractions. We're going to take a look at cases 3 and 4. Case 3 we have here the partial fraction decomposition of p of x over q of x, where our denominator q of x has a non-repeated prime quadratic factor. Okay, so before we start, we need to understand a couple terms. Okay, let's explain this prime. So let's make sure you understand, and that means we can't factor it. So basically it can't be factored. We say if a of x squared plus b of x plus c is a prime quadratic factor, the partial fraction decomposition now contain a term of the form ax plus b over ax squared plus bx plus c. Okay, and then if you look right here, we talk about linear. Okay, I'm just highlight really quick linear. That means, you can think this way. If you have a quadratic factor, which is denominator, the highest power is 2, and then linear, the highest power is 1. Okay, that's how you remember it. Example 3, find the partial fraction decomposition of a 3x squared plus 17x plus 14 over x minus 2, x squared plus 2x plus 4. How we set this up? Let's take a look at piece by piece. Let's look at the first part. So we'll talk about first part, x minus 2. So you have to recall, okay, what was the case 1? Case 1, we were talking about linear distinct. So in this case, we actually have a linear, right? So that means this is actually case 1. Because we have linear, there's no power. Let's just go ahead and set up the first one. That will be a over x minus 2. Now we're going to look at the second portion, x squared plus 2x plus 4. So when we look at this, we have to think, is it prime quadratic factor? It does look like the x plus 2 squared, right? You think that way. However, it's not the case. They're different, because if you think about this, it's x squared plus 4x, but we have x squared plus 2x. So in fact, this we can't factor it, okay? So that means we have to use this. So can't factor, we also don't have a power outside the parenthesis. That means satisfy the cases 3, which we just learned, okay? Alright, so which means we're going to write this as bx plus c form, because we said if we have a prime quadratic factor. And then if you look at this, okay, I'm going to highlight really quick. This is have an x squared. Then you gotta remember the numerator must be less power than this. Okay, that means it's x to the first power. That's what they're talking about. The top is the linear. Once we set it up, well, I just write it down really quickly, because we know whatever is the denominator given to us, that is we're going to multiply every single term by this. Of course, once you get used to it, you really don't have to do this. You just do it in your head, that's fine. So I'm just write it down, tell you guys where that come from, okay? Alright, so in this case, we're going to cancel them out, right? So they're going to be canceled out. So the left side, all I have left is 3x squared plus 17x plus 14, then equal to, and then we look at this, we're going to have x minus 2 canceled. We're going to have 8 times x squared plus 2x plus 4, and then we'll look at the third term right here, bx plus c, okay, and then we'll look at the denominator, so what is canceled out? So we're going to have cancel out this part. And then we're going to have a bx plus c, and then what's left is x minus 2. Be careful, you got to write down the parenthesis, okay? Bx plus c. Otherwise, you're going to make a mistake. We're going to have a ax squared plus 2ax plus 4a, okay? And then the second, we're going to have a bx squared, and then minus 2bx, and then plus cx minus 2c. So once we have this, we're going to collect like terms. Let me use a different color. So we have x squared here, we have x squared here. We're going to leave the left side alone. We're just going to bring it down. And so here we're going to collect like terms. We're going to have a plus b, and then have an x squared. So then we're going to collect the like term for x. We have x here. We have another x. We have another x right there. So we're going to put them together. That will be 2a minus 2b, and then plus c, and then x. And then the rest of the stuff is just going to be constant, right? So we have a 4a. We have a 2c. Anything else? No. So we're going to put them together. That will be plus 4a minus 2c. So put them together. So now we're going to match it to the left side now. So left side we have x squared. So we can set this up. 3 equal to the coefficient for the left side is a plus b. And then we also have our x, the coefficient is 17. That will be equal to the right hand side. That will be 2a minus 2b plus c. We also have the constant, right, is 14. And then we have the constant right here. That will be 14 equal to 4a minus 2c. So now we have a system with 3 variables. So we can rewrite this as the term a plus b equal to 3, and then 2a minus 2b plus c equal to 17. We can rewrite this as 4a minus 2c equal to 14. So once we write this, the rest of the stuff, you have been doing for a while. So we're just going to solve the system equation by using any method. For saving time, I'm just going to do this very quickly. Okay, you can use substitution method, you can use addition method, or you can just use matrix to solve this. That's fine too. So our a is equal to 5, and then b is equal to -2, and c equal to 3. So our final solution is, we're just going to bring this a, b, c back here. A is 5, b is -2, and then c is positive 3. So now I'm just going to do a substitution and write down my answer. So this is just going to be equal to 5 over x minus 2 plus -2 plus -2x plus 3 over x squared plus 2x plus 4. So that is my final solution for this question. Okay, let's go ahead and work on case 4. So we have the partial fraction decomposition. So when we have the denominator, q of x has a prime repeated quadratic factor. Okay, when we talk about repeated, that means outside the parenthesis must have a n power. Then we're also talking about the prime quadratic factor, which is the same thing we learned at case 3. It's just the quadratic, we can't factor it. We're going to have p of x over a x squared plus bx plus c. Again, this is the prime, it can be factored, and then to the nth power. So if you have a repeated, that means outside it must have an n power. Okay, if that's the case, which is case 4, is similar to case 2. So we're just going to write the denominator to the first power, right? If you look at the denominator. So here we're just going to end up with the first power. Then we have a second power. Maybe I use red. This is first power, second power, third power, until it's the nth power. Okay, until it's the nth power. Then you look at the numerator. Let's look at the numerator really quick. Each numerator is always linear. Okay, always a linear. So this is also linear, and this, all they're linear. Alright, let's go ahead and take a look at example 4. So example 4, we have finding the partial fraction decomposition of 5x to the third power minus 3x squared plus 7x minus 3. And the over, there's a whole thing, x squared plus 1. And then the outside is the second power. So we're going to look at inside the parenthesis first. So it's x squared plus 1, because it's a second power here. So we can't not use case 1 or case 2. Okay? X squared plus 1, we also should realize that we can't factor it either. So don't be mixed with x squared minus 1, because that one we can't factor. We can't factor the x squared plus 1 we can't factor it. Okay, they're different. Now we also look outside what is the exponents. In this case, we have an exponent 2. That means we satisfy this case 4. We have a prime, we have a repeated quadratic factor. Now we're going to set it up. This is going to be equal to, we said the denominator must be x squared plus 1, that's the whole thing, to the first power. Then plus is the whole thing, have the second power, right? Our n in this case is just going to be 2. Okay, then we stop right there. If we have x squared plus 1 to the third power, if the question here is the third power, then we have to write like this form. Okay, so since we have the second power, so we're just going to delete this. Okay, so then we also look, okay, what I'm going to put for the numerator. Remember, anytime you're dealing with a quadratic on the bottom, the numerator is linear. That means it's one part less. We're going to have ax plus b. And then here we're going to use cx plus d. And that's how we set it up. We've done it so many times. We have to multiply this every single term. Let me just write it really quickly. We're going to have 5x to the third power minus 3x squared plus 7x minus 3. And then here we're going to cancel one of them, right? It's x squared plus 1, because this is only the first power. Then here we have a second power. We're going to have left is ax plus b, the x squared plus 1. So then the third term, we're going to have a cx plus d. They're going to be canceled out. So we're going to have only cx plus d left. Okay, so then we're going to simplify this. The left hand side is exactly the same. So we're going to work on this on the right hand side. That will be a to the x to the third power, and then plus ax. And then we have a plus bx squared and then plus b. Okay? And then we're going to have plus cx plus d. And then the left hand side is just going to be the same. I'm just going to write it down. We're going to continue this. We have x to the third power. It's just by itself. We're going to leave that alone. We can't group them with anything. And then we also have a plus bx squared, so there's nothing else. And then now we look at x. We have x here. We're going to have x here. So we put them together. We're going to have a plus a plus a c, the parenthesis x. And then now we're going to look at what's left. We're going to have a b and a d. They are the constants. So we're going to group them together, b and d. Okay, then we're going to look at the left side. Let's compare this, okay? We have an x cubed here. We're going to have an x cubed here. So then I realize my a is just going to be equal to 5. Then we're going to do the next one. We have here, right? And then we have an x squared here. So I'm going to have a b equal to -3. I'm just writing the constant to the right hand side, okay? And then the next, we're going to match the x, which is, if you look right here, the coefficient is 7. So we're going to have a plus c equal to 7. And then the last piece, that will be b plus d, that's the blue color. That will be equal to this side, that is -3. So that is how to set them up. This is very easy to solve. So we already have a b. So let's go ahead and figure out what's our c. So since our a is 5, just do a substitution, and plus c equals 7. This will give me c equals 2. And then the next is we have b equal -3. That plus d give you -3. Then we're going to have this whole thing give me d equals 0. So I can write the answer. Our a is 5, b is -3, c is 2, and d is 0. So now I can go back and write down the answers, right? So we can just highlight it. So my a goes right here, and then my b is -3, and then my c is right here, is 2. And then we also have a d is 0. Okay? So let's go ahead and write down our answer. So our answer is going to be, so a is 5x plus b, that is just going to plus -3. Okay, which is just going to be -3. Let's just go ahead and do that way. That will be -3 over x squared plus 1. And then the outside, then we're going to plus c is 2x, and then d is just going to be 0, and plus 0 right there, and then over x squared plus 1 is the whole thing squared. So we can just going to delete this 0. Okay, we don't really need this. So that is your final answer. Okay, so that is our case 3 and case 4. So thank you very much for watching the video. I'll see you guys next time.